All right, hi everybody. We're working through the Diploma prep material. This is a chapter on polynomials, and we're looking at a question about the integral zero theorem. Now, that sounds a lot more intimidating than it is, but what it says essentially is this. If I was going to multiply out, let's say, three factors here, so x minus a, x minus b, x minus c, to get this expression right here, the last three terms, or the last three factors that I put together will be a, b, c. That will correspond to the last term here. Okay? So any factor that I'm looking for, any binomial factor, the constant in each of those has got to be a factor of -2. So these are the possibilities, and I'll write them up here, will be x, let's say x minus 1, x plus 1, x minus 2, x plus 2. These are the four possibilities for factors that I'm going to have to check first. And I'm supposed to use the remainder, like ultimately, I understand that we're going to end up factoring these things, or sorry, graphing them on the calculator and doing factoring like that. But what you're supposed to do is to take a look at the possible factors, and let's just choose like the first one here by plugging in +1. So this will be 2 times 1 cubed plus 3 times 1 squared minus 3 times 1 minus 2. And you see, that gets me a 0. And so I know right now that x minus 1 is a factor. Okay, so x minus 1 is a factor. So now what I'll do is I'm going to go to my synthetic division. I'll plug in my coefficients there, and I'll just do the division here. So bring down the 2. I'm going to multiply and add, multiply and add, multiply and add. And so now that's my remainder here. And I'm going to end up with this as my quadratic, so this will be x minus 1. Don't forget about that factor, times 2x squared plus 5x plus 2. And what we're hoping for by this point is that this quadratic is relatively easy to factor. And it turns out it is actually fairly easy to factor. This ends up being +2, and then this requires, this must be +1. And so that's the factored form of that polynomial.